Real quick, this video is totally optional. The more I thought about it, in the first video I just made the comment how when it comes to put options and intrinsic value, the math is just this, reversed around in the opposite. But you know what? I figured why not just do it real quick? That way if somebody's unsure, then they can watch this video and get kind of the other side of the coin. But if you understood what I meant by everything is just the opposite, then you really don't need to watch this video at all. It's going to be short, so let's just hop right in. Let's take a look at intrinsic value for put options. So like I said, everything is the exact opposite, and as far as the math is concerned, nothing else changes in terms of the equation. That's the same, the relationship is the same. It just comes down to the math. So when it comes to a put option, if the math gives us 0 or a positive number, remember for calls that would be a negative number, but since we're talking about puts, if the math gives us 0 or a positive number, that would be considered out of the money. On the flip side, if the math gives us a negative number, again, for calls, that would put us out of the money if the number was negative. But because we're talking about puts, a negative number would put us in the money. So let's look at some examples. These examples should look very similar because they are the exact numbers, but let's just see how things play out. So back to scenario 1, we have this stock ABC and it's currently trading for $36 per share. We have a put, so key thing here, we have a put option strike price of $32. So let's figure out the relationship here, the intrinsic value, and go through our equation. $36 price of the stock minus $32, the strike price is $4, a positive number. Because 4 is positive, and we're talking about puts now, that gives us out of the money. So we are out of the money on this because the value is 4. So we would say that the option does not have any intrinsic value. So when we hop down over to our relationship status for this, the answer would be no. Scenario 2 and 3 here, again, stock ABC is still currently trading for 36, but then it does make a move up to 41. At the same time, let's now look at a put option price of 41. So let's figure out the relationship here. So in our first example, scenario number 2, where the price per share is still at 36. However, the one thing that has changed is that we now have a put option price of 41. So that is the difference. So price of stock 36 minus the strike price 41. That gives us -5. -5 is obviously a negative number. Therefore, in this case, with the put, we are now in the money. So we would say that the option has intrinsic value of $5 per share. Now let's figure out when it moves up to 41. What does that do? Figuring out the relationship here. Price of stock has risen to 41. Our strike price is 41. That gives us 0. So just like the calls, we would say that the option does not have any intrinsic value. So for our first example here, when we had the -5, that would give us yes, we have intrinsic value. For the second one down here where it gave us the 0, that's where we would have to mark no, there is no intrinsic value. But again, in terms of quote-unquote closeness of intrinsic value, obviously 0 is much closer than +4 from the previous slide. This one is tilting right on the edge, but technically speaking, that 0 still does give us no intrinsic value, but it is much closer compared to 1 or 2 or 3, or in our example 4 being that positive number. So that's it. That's the only difference. The big difference is positive is good for calls, negative is good for puts, and from there, that's just as simple as that. Like I said, nothing huge, but the more I thought about it, I thought, why not just make a quick little video, explain it, and that way it's out there just in case somebody wants to see some visual representation of how a put would be different from a call.